Hi everyone, welcome to my channel. So today I I have a new topic which I think is very common and is being used while designing the data pipelines. It is full load versus incremental load. So the problem we face with the full load versus incremental load is we spend a lot of compute when we run a full scan of the records while running your pipeline. So there are two things which really matter. Is like first of all, it slows down your pipeline when you don't need to read all the records and you just have to read the incremental or the changed records, which is called as CDC as well. So this is I have prepared. Why does it happen? So it's like your pipeline is somehow affected by the weight of the redundant data, and it does affect your pipeline performance. Um, so then you actually need to refine the logic of your pipeline and just need to read the incremental data load instead of reading or scanning the entire table. So because if there are a million records and if you are not just reading the changed records, you may have to go through the 100,000 or a million rows, which again, it's not an efficient way of designing a pipeline. So again, it's one of the topics wherein how can you use like incremental load and what are the steps? I mean, how do you implement incremental load while creating your pipeline? So let's get started. Without Yeah, let's get started. So I have so let's so my focus is to show you like how incremental load works. Again, because it's very critical from a production system version whenever you are running the pipelines or the jobs, which does have the production data. So you need to design your pipeline in a way wherein you are only reading the changed records. So this is something which I've picked up using Claude. You can guys also use Claude to understand like you can understand the topics in depth, which is really cool. You need an AI assistant tool, as I always say in my videos, because somehow it help you to understand things easily, and also at the same place. So for me, so for example, for the full versus incremental load, there is an example given wherein you have I've created synthetic e-commerce events, which run both a full overwritten and incremental load back to back, and then we prepare a cost versus time comparison table, so the performance gap is measurable. So I'm just trying to show you with an example how how it affects. So here you can see I've defined the schema. I'm actually creating two data sets, small and large. So one has 50,000 events, wherein the other one has 5 million events. So there is a huge gap, right? And I'm using them. I'm not actually reading and data from open source. I'm just creating synthetic data. I mean, it's your choice. It's just for understanding, because when you import a data set, you need to also have an understanding of the data set as well. But for me, my focus is to actually explain how the cost versus and time are impacted whenever you have an incremental data load versus a large like full data load. So as you can see, this is a data set for small. Similarly, the same data set is being used. And also what you can do is you can count the number of rows, right? Just want to see the count. Actually, it should not be like this. It should say df small dot count. So now we will be able to see the number of rows. Row counts 50,000, wherein I would say df large. I mean, I like to explain by doing things instead of just explaining you through slides. I mean, it is good, but again, you need to know because whenever you run the code, there are multiple failures, which is normal. Your code is not perfect in the first go. So now you have what I'm doing is I have these two data frames, large and small. One has 50,000 rows, wherein the other one has 5 million rows. So what I'm going to do is now I'm going to write these two sources as a delta table. Let's run this. So what does it say? Public DFS path root is disabled. All right. So what I'm going to do is base path access is denied. Let us see what does Genie, because this is what happens in real scenario things. There will always be a bit of gap. So you have to understand this. I know it's not a huge, but I still make use of Genie because I want to show wherein things fail. And I know what is the error, but again, it's basically you have to write your delta tables into your catalog, right? Um, Let us say, what does Genie suggest, Because my point is not to just show a smooth notebook wherein you do not have any errors, which is not the real case scenario, right? Because things often go wrong. I mean, that's how I understand. So my focus is on to show you each bit of error you will encounter, right, while you are doing things. So it says it wants to change two cells. I don't know why does it want to change two cells. Only this one I want. Allow. I did allow it. What does it? Did it change? I have no idea. Let me see. And I have to still see where these tables are being written, right? Um, so this still says, mode override, write a small table. What did it change? Let us see. Except this one first. All right, this ran. So base path is this, right, for me. And let us rerun this one. I actually show, like, because I know that there are often errors, and it is normal to have errors unless you are not doing if it's, but in the production environment you have to make sure how many records are being impacted by the error, right? It should run. What is it saying? It says file not found, user. Let me see. What does it say? So basically, it just want to write a path, right? Wherein what we do is create a catalog, right? Why do we have to struggle this much? Um, it's basically where you want to write your, I mean, events, like wherein you want to. So what you do is you copy this, and it would be able to write it. Why I have to struggle. So what I do is I put base path base path as this thing, all right? Why, base path is just give me a moment. Does this work? So my base path is this now. Let me check again. Path must be absolute like this, right? Let me see what does it needs an absolute path. Allow, yeah. It will check the catalog first, where what my catalog is. So this is my catalog, right? Allow schemas. So I have the engineering March. That's what I did. Let me update the cell 3, So it's basically the path wherein you want to write the table, except, does it say allow? Let's allow this. I mean, that's what I really like. I debugging is part of your. I think if you are a data engineer, debugging is very common. You wouldn't say it's not there, and you start liking it because after some time you kind of understand how things work. It should work this time, right? And it will. So it's you need an absolute path. I was just putting up the schema catalog and schema. Can we check now whether these tables have been written or not, right? Let's go here, refresh it. I mean, I'd like to show every part of it because I think it kind of helps, Bronze, I don't know where is it. Let me refresh it on the top. Um, can we see anything in here? It's still not written because, all right. So let me see. Let me see the tables, right? Even small. Use even small, right? Select asterisk from even small. Select count asterisk from events small, right? Events small. And what I can do is I have to use the whole path of it so that because I just want to see whether it is even created or not. I would do is so there is no table as even small. I have let me see. So it's still not there, right? I have to still check where in the table have been created. There was an absolute path, right? So I have data pipeline 26, then you have a default, then you have pipeline module. So where I was checking was wrong. I have created that you have created the table in the volume, right? So pipeline module, right? So there are two files in here, bronze, even small and event large. So we have created actually the yeah, two files. Let me see. So basically it has created under the pipeline module and it's a volume, right? Um, Event small, let me see. So you can see that, there are multiple, let me see what does it look like. So if you look at this file, it's a Parquet file, right? So in the Parquet format, these files have, and the data is in Parquet format, right? Let's make use of it the way it is. But here I can see we simulate a bronze layer raw events table with growing raw count to replicate real pipeline pressure. Create a Unity catalog volume for data storage. We created a Unity catalog volume within that. Use Unity catalog volume path, right? ठीक है. And then what you do here is write source tables. So both tables are purchased as delta table and bronze zone, right? Now it actually shows how you make use of bronze layer, to read the tables. And let's move forward. I can't see. You can still see it if you. What you do is so bronze, right? You go to events more and you copy this path. You know, you can still see it as a table. So that's the beauty of Databricks. And I have to see how does this show. Because there must be a format to read the Parquet file. That's how it is. Limit. You can always see, even read the. So can you rewrite this? Like, let's use Genie 2. So you don't skip steps. You go through. Can you rewrite this? So my whole focus is on to show you things which can really help you understand. So can you see syntax error? Let's see what is a syntax error. I mean, I could have skipped this step and gone straight away. All right, let's see. There is some error, delta dot something, right? So that's the beauty of Databricks. That's what I really like about Databricks. Even read the data from CSV file or from a Parquet file, which is cool, right? And you can also see the number of records. So you don't necessarily have to put up in a table to even see. You can just see the data as it is. Before you, let's see the 10 records, right? Yes, you can see, right? There is an event ID, and this is actually a real use case scenario wherein you have events at every timestamp, right? And there is a charge associated with the product, right? So anyone who's working in a product domain may understand this, right? So let's discuss now how do we manage, how do we actually use the compute resource efficiently and minimize the cost by not doing a full load, because full load in so many cases is not required. You just need these changed records, incremental load. What I mean, you can call it in multiple terms. So the way you understand. So legacy approach, which is like an old school approach, wherein you read all the rows, transform them, and overwrite onto the target, right? And which again has its cost. So a data engineer would avoid that cost. That's what my whole motive here is to share the knowledge with. The reason, I mean, why people are not able to move away from the full load pattern is it's easier to understand and simplement to implement. No state management. Guarantees a clean slate, no duplicates from merge logic, right? And wide breaks at scale is sometimes, I mean, there is a single row which you want to rewrite, which you want to update, or like there are multiple records which you want to update. What would you do, right? So read and rewrites every row, even unchanged data, right? If the data hasn't changed, why do we actually need to rewrite it, and also avoid the compute cost, right? Which is a huge debt, right? Technical debt. If you like scan the whole table first and then rewrite it, truncate and load approach, right? I know that if the table is a small table, right, and you want to rewrite it, that's okay, right? If it has like billion records, again, it's gonna take a hell lot of time. Your clusters will be busy, and also your compute cost would go up. You'll be losing a lot as compared to what you are gaining. So, and it has to do a lot of shuffling, right? As I explained in my last video, if you do not understand how shuffling works, you also need to see the query. I can still show you the query profile, but I would not be going in depth how the scanning works, when does shuffle happens, when does join happens, how does the aggregation leads to shuffling of records. So let's create a silver table now, using the bronze table. So these are wide breaks at scale. Cluster must hold the entire data set in memory or slash shuffle. Um, Cost scale linearly with table size, right? That's what, as I said, cost is something which concerns every data team, especially for a cluster or compute. Long run times block downstream consumers, right? Yeah. Again, if your pipeline is taking forever to run, your data final data source won't be updated, right? And the visualization dashboard, or like the dashboard which is dependent on that final data source, will not refresh as well. So again, a delay in the decision making, even for the people who make use of dashboard, right, to make decisions. So let's run this now. So it says target path has an issue, right? A schema mismatch detected when writing to the delta table. Enable schema migration using data frame write, or please set option merge schema is equal to true, right? So let's set this. What, I have no issues, right? I can, you know, yeah, just say here, right? What's the issue, right? So if there is a change schema happening, right? Yeah, so it will work, right? So you have to understand the code first. Don't worry about syntax too much. If you understand things, it doesn't matter whether you are using PySpark or a Spark SQL, right? As long as you have an understanding of what's happening. So full data load is 50,000 rows for small data set. And for a large data set, it's 5 million rows, which is like a good amount of rows. And it does happen in production environments. So what I've done is, and you can see these tables wherein they have been written, small data set, where have been they written. Let's see, I want to check whether they have been updated in here, where they have been updated, right? I want to see, does it have silver, right? Now I have a events full load, right? So this is there, right? It's still in a Parquet format. So I would look, go again here. So in here you have silver, this one, right? In silver you have events full load, right? And you can see there are multiple Parquet files. I mean, because you do it in batches, right? That's what happens. So so what it did was, takes the data from the source path, writes onto the target path, and even for small and the large data set, full load data set is this. Run full load on small data set. All right, 50K rows. Um, Small data set, rows processes 50,000, elapsed time, strategy. Let's look at the incremental load pattern. This is the more, I mean, it's like you only change the records. For example, there is an example given. On day 90, only 55,000 rows arrived in last 24 hours. There is no reason to reprocess it, which is correct, right? You don't need to process all the records. So let's see. So what it's doing is we're creating a watermark path, which is again There will be a folder, there will be a watermark and events watermark, right? So what we do is get watermark, right? So we get the latest timestamp from the watermark store, and then we see load that watermark path, right? And select maximum, the most recent timestamp, right? That's what you do. And you say, oh, this is just to pick up the watermark, right? The latest timestamp for the watermark from the watermark path. You save that watermark path, and then what you do is then you do an incremental load. Only process rows newer than the stored watermark, right? It's like if, for example, you had latest records until Thursday, um, and there are only few records which have changed. So based on that timestamp, you only modify the records which are required to be modified. I'll show you, So you read it, the load source path, filter only to new records since the watermark. Only the records which have changed, they need to be transformed. And same transformation logic as full load, right? So you have event type is not null, amount USD, load timestamp, load strategy, row count. Let's run this to see. So you have to practice a lot of code as well to even understand. Because I mean I've been doing it for a while now, so I kind of understand it. And I you so rows processed is 5 billion, right? Elapsed time is 8.41 seconds, right? First run, no watermark. Strategy is incremental. So no watermark found. This is the first run, right? Watermark saved is um 29 12 2025. Simulate a second run, right? Only new data arrives. We append 55,000 new rows and rerun the incremental data pipeline, right? Let's run this. So in the earlier case, we are showing a gap, right? When there is no new watermark, right? So it process all the rows, right? Incremental load. So there was no, it was doing for the first time, so it loaded all the data, right? In the second run, only the data which has arrived new, it is being changed or it is being modified, like whatever you want, transformed. So appended 55,000 euros to bronze. Watermark was this. Can you see there is a gap 29? Although they are on the same date, but the timestamp is different, right? If you look at the timestamp in here, 33, this is 206. Watermark saved is this, right? All right. So now what we can do is now do a comparison summary, right? So 50,000 overwrite all, right? 5 million overwrite all. 5 million append, no watermark, right? Append watermark delta, right? So sorry, it shows you how you can use make use of watermark. And let's see the table as well, right? What has changed in here? I always like to go to catalog and see the changes, because that enables, like, there's a watermark folder, right? Then there is events watermark, and now I can see there are two files, right? 2 minutes ago, 1 minute ago. 1 minute ago has a different watermark timestamp, which is last process timestamp. So yeah, and like I like to understand them every bit of it, like instead of just skipping and running on to like that's not what I really like. I like to do things in a step-by-step format, so that even the person who's doing it can understand it, right? So I will also share these notebooks on the GitHub folder, the GitHub repo, which you can find the link below, so that you can make use of them to understand how the full load versus incremental load works. And I'm not sure whether there are many videos on YouTube which even show you how does this incremental load. Even the Databricks doesn't show you, right? Like I've been to the events. I'm not going to comment on all those things, but It's like it's on the surface level, which kind of not helps, like, I mean, that's what I've seen. You may go through the entire video and at the end you have nothing in your head, right? So yeah, so let's move on to. So this is because I created a set of 5 notebooks. So watermarking framework. Watermarking is nothing. It's just to understand, like, what does a watermark means, right? So it's the latest timestamp. Based on the timestamp, you decide whether you want to change the records or not. It's like a CDC, right? So that's in simple terms. I would not like overcomplicate things. I want to keep them simple so that people can understand, and you can see, like, even your notebooks are like this, right? You have all the notebooks in here, right? The first notebook, second notebook, right? And if I go back to my workspace, I can open the third notebook in here, right? I mean, yeah, that's the best part about Databricks. I can have all my notebooks in here and do a side by side comparison. And I like, let me show you one more thing. Um, there's a version history, right, for Databricks, which actually helps you compare your code with your previous version, right? Since I haven't run this, right? So what I will do is, let me go to my first notebook, right? I am not sure whether people show you in this, whether it is, because it is an important feature. You can see, right? Based on your timestamp, you have different versions of your notebook, and you can do a side by side comparison. How cool is that, right? You don't have to paste it manually in a notepad to compare your code, which again is not an efficient way of coding in 2026, especially SQL and or like PySpark. So let's deep dive more into watermarking. So as I said, we had the bronze table, we have silver table as well, right? Based on the timestamp, we have I've shown you how incremental data load works. So what are we focusing on? How can we create a production grade watermark store using Delta Lake? You implement a high watermark logic using both timestamp and sequential ID strategies. Handle pipeline restarts and cluster failures with a safe state recovery mechanism, right? So what I would do is, I just copy the base path from in here, because again it would, let's see. So let's run this. And you don't even need to start this Spark session, right? In Databricks, you can just get it started. Like, this is not required. So OLTP system. So you have to also understand there are OLAP and OLTP transactions are like they are usually the transaction systems, and analytical processing systems are different, where you have millions of records based on events, right? I'm doing based on the batch. So that's something which you also need to understand. Row orders feed from generate the bronze source table, right? So what I would do is, bronze, and then I will create an orders, and silver then in orders, the watermarks and order watermark, right? Let's run this. Create orders patch. So start ID plus n. So first column is ID, second column, yeah, let's run this, and I think by this time you would be able to if the more you practice things, the better you get, because the things which you look for is what are the columns and what are the derived columns and how they are being created, right? And whether you are writing a full overwrite or as a delta table onto the bronze path, right? So these are all the things which you look for. So let's run this. So you can see bronze orders table have been created with 75,000 rows. Let's see, whether does it have those table. Uh, uh, Bronze, there will be orders table, right? Now you have, yeah, it's like a Parquet format, right? You have multiple data, right? So, and do you want to see the table? It has 75,000 records, right? So let's, I mean, you can use the same. I'll be sharing these notebooks. You can use them and to understand at each step, whether you want to see the number of records, how do you see them. So first strategy is use a time-based watermark. As I mean, it's similar to what I did in the first notebook, but it's a bit. It is like it is more something which you can. So you take the maximum created timestamp. Earlier we were just doing picking up the maximum timestamp based on the just and putting up in the source folder, which is watermark, and then picking up the value, and then based on that we were doing it, right? Now what we do is we take the maximum created timestamp process so far. Event-driven sources where records have reliable timestamps, clock skew, or I mean event-driven, because most of the even the batches they are driven by event timestamp. So can cause missed rows. Use a small look-back buffer. Example: subtract 5 minutes to compensate. Right? Yeah, which makes sense, right? Your records may sometimes arrive late, right? It is due to the previous batch run, which are actually populating your source table, right? So that can happen, right? So you created a class, then you have your path is same, table name, and look back seconds, right? Then you see whether there is a watermark which exists. If it is yes, that's good. First run or store is missing, buffered watermark. So buffer is like you're taking a 5 second delay time, right? The gap between your actual timestamp which you're expecting and which is the maximum created timestamp, right? And then you look back 5 seconds before, in case there is a delay, right? So or it may have arrived earlier. What like you can also put +5 as well. It's just -5. You can also put as +5. So up to you, like the way you're designing your data pipeline. So let's run this. Um, so I'm not sure. We will compare it, right? Now we are using ID based watermark, right? Which is the latest ID, right? Order ID processed so far. Tables with monotonically increasing surrogate keys, right? Auto increment primary keys. Immune to clock skew. No look back buffer needed. Does not capture updates to existing rows. Only insertions, right? So let's run this. It's based on the ID. We do not have a buffer here, because we just look for the latest ID, based on that ID, we pick up the new records, right? That's what we do. So yeah, let's run this. All right. Let's first run has note watermark, process all seven. So initially when for the first time when the records are arriving, right? So it has no watermark. Let's run this with timestamp watermark. Silver, append to silver, right? So what does it happen? Did it show up an error or 4 by 5 completed? What has failed? So let's see. Why has it failed though? It says there is something with the it full backfill. Let's see. What does it say? It has failed on the last attempt because others are like calling the functions, right? So let me see. Why does it fail? incremental load with timestamp watermark, bronze path, silver path, timestamp watermark, right? Let's go in here, right? Why do we have to struggle? Event watermark, order watermark, timestamp, right? So this there, right? There is a timestamp watermark. Orders updated at this, watermark timestamp is this, right? Let's move ahead to see new batch, 8,000 orders in the last hour, right? Start ID is this, number of rows is this, time stamp offset hours is 0. So let's run this. See, so there should be another timestamp silver path. If you go to let's go in here, pipeline module, silver, like events full load, events incremental load, orders. No, not this one. Watermark. Yep. So wherein it has created only process the 8,000 euros. New batch dot count 8,000 rows, right? To bronze path, right? Let's see what is the incremental load with what timestamp watermark. What is bronze path? Let's ask Genie, right? What is the bronze path here, right? So it will show you, right? So now I've rerun this. So my bronze path is this one. New batch appended is 8,000 rows have been appended. So what is this function doing is new batch, right? You create orders for the new batch and then you append them to the bronze path, right? So then you say these number of records have been appended. So this function actually calls your create orders. This calls you add in 8,000 rows again. Start ID with this. What happens if the cluster dies mid-run, right? If the cluster dies before save executes, the watermark stays at the previous value. The next rerun reads the same window of data. Duplicate rows may be written to silver append mode. Yeah, use merge notebook 3 instead of appending. So you can also like if your watermark wasn't updated and your cluster has failed, or due to some reason the job has failed, right? You may never know. There can be so many reasons for job failing. Let's see the watermark state inspection. What current timestamp watermark, silver table row count, watermark store history, So this is my watermark timestamp. It was updated on 29/3 at this time, Silver table row count, number of output bytes, number of removed files, number of removed bytes. So you update, you add the records, you update the timestamp based on the updated timestamp, you append them onto your batch bronze path, right? And the bronze path is this one, right? Bronze orders. And what you can see in here, go in here, bronze orders. What you can do is I want to read all the records from orders, right? I want to record all the records from orders, right? Let me see, how it has changed. I mean, you can think of things, like let's select asterisk from this, right? I will say to Genie, can you provide me to select to see 10 records from this, records from orders, orders. So it will help me to see, let's see, And so this is right there, right? And based on this, what you can do is you can get the maximum created at, or what you can do is like, let me see, count asterisk um, based on created at, right? Created at, created at, and what you can do is group by all, right? Now you can see the number of records based on created at, right? So you can see a count is, and yeah, so this is how it is, right? I'm just seeing 10 rows. You can have a lot of records, and you can also see order by created at DESC, right? Order by created at DESC, right? Limit 100. So, so you can see the latest timestamp we have is 31/12/2024. Similarly, you can do the same thing for your silver table, right? Silver table is the one which has the appended record, right? In bronze, you pull in the records, but what you do is you go in here, you go to silver, right? You go to orders and you copy this path. What you do is you paste in here first. Silver orders, right? So just have to change this path, and this is there. Now first of all I need to see how the records look like in silver table, you know. So at each step, if you check, see the records are good enough, like you see the table, right? Although it's saved in Park, but it's, yeah. So you can see that order ID, customer address city. So transform that, right? So what I will now do is, I'll see count asterisk, transform that, right? Um, transformed at, right? And what I would do is group by all, order by transformed at, transformed at, right? This one, right? It will show you when the data was transformed. So you can see, right? 49,000, these were transformed at this timestamp, right? 26/3/2026. So yeah, like this is how it is, right? I also check in detail, right? Whatever happens, right? Um, and also what you can do is, you can see the details in here, right? Um, and overview. So for example, silver, right? Orders. So this actually acts like a table, right? But since it is in the Parquet format, it won't have the history in here, right? But again, what I can see here is, you are loading the silver path dot count, right? Then you are counting the number of rows in the silver table, which is 87,026, right? Does it match with what we have? Let me check here, right? Because you can always check, right? Like, come back and just create another code cell, run it here. Look, I am just trying to understand things in a better way instead of just, rushing through things. So you can see 49,967. So what is this row count? Silver table row count, right? Format is delta, load, silver path. Let's see what silver path it is, right? What is silver path, right? Print Can you tell me what is the silver path, right? Print silver path. I'll ask Genie to write this. Can you rewrite this? I'll create a separate code cell to see. So silver slash orders, right? But if I go in here, so you have to refresh it to see silver orders. So yeah, all right, let's move ahead. So this is to show you how you can append records based on your watermark timestamp as well as based on your ID, right? And there is something which I forgot to show. This is something which you did based on transform that, right? Let's see based on ID, right? ID, order ID, right? Let's see, I have no idea, like, because I want to see things, let's take a bit deeper to understand. So can you see that based on the order ID, right? You have different timestamp. I think transform timestamp is correct, but there are order count is varying, right? I hope this kind of explains what I'm doing, because I think I'm trying to explain in depth. Um, I wouldn't say that it's an introductory video. It starts from basic, but it goes to level 3, level 4, right? It depends. Like it is like if you really if you really want to deep dive into data engineering, then yeah, it is recommended for you to please um, like and subscribe my video, and this will help me to make more videos. And let's move on to the next merge operations, right? Let's see this one. So this is again, right? Like when there is a CDC, right? When there is a change data happening and you capture that incremental load, and then you only update those specific rows instead of doing a truncate and load. Truncate is like there is an existing table um, which you empty, right? Um, and the schema of the table remains the same. Whereas in overwrite, it also changes the schema of the table as well as overwrites the records. So let's, for us, the objective here is executing high performance merge operations. Um, I know it's a lot of content, a lot of knowledge which I'm sharing, and it may be a bit overwhelming at first, but um, if you need to pause and um, need to take a pause to understand it and revise it, please do so, because it will take you a bit of time to even understand. It's not something which will happen on day one, as I recommend to people. It's a slow progress, because these are a lot of things happening, and I am trying to keep them a bit by bit, right, step by step, so that it can help people, right? Because it took me a long time to like come up and share my knowledge, because it is again a lot of time you invest. So please take a pause, and if you want to rewatch the video, please do so to understand things. So so what I'm doing here is I'm executing high performance merge operations. So again, my whole point of this video is data load strategies. When you should choose to have incremental data load and when you should have do the full load, right? Because in certain scenarios you may need to do the full load. I'm not saying you will always do the incremental data load, but again, like 80% of the cases you will be doing incremental data load, right? When you're doing the transformation at the silver table, or yeah, that's what happens. Let's I mean, this is again, I will just use the path. Let me see, can I change the path? So, what I would do is, let's use the path again, same path. What I would do is pipeline module. Again, I would create a pipeline module. It's I'll write merge operation or something, right? Merge ops, so that I'm able to distinguish it, right? That's what I want to do. So let's create this. Let's see, so that I can separate them from my previous files. Yeah, it's not gonna auto merge, right? So what you do is just keep right. Let's run the same. It doesn't matter. I have no idea why auto merge is enabled is not available. So let us see. There is a feature in Spark session, right? Like it's saying auto merge is not available. Let us see why does it show up an error, right? Spark.databricks.delta.schema. Don't know why it's taking this longer time, right? Let us see. Definitely, it's not the internet connection. So I'm just. It's. I think this is not available because of the serverless which I'm using. I guess. Maybe just. Uh, Maybe just what you do is comment it. I don't need to waste my time on this. Spark session is ready. Now what you do is like SCD type one, right? So this is again merge, like this merge and update. These are part of SCD types. And there are different types of SCD, slowly changing dimension. But first is you overwrite onto the same record on the same column, right? That's it, SCD type one. For example, a record has changed. You don't keep the history of the record. You just write the new value onto the record itself, right? So let's see this first. So you have initial state 100,000 customer records. So I'm creating initial data frame, right? Let's rerun this. Then you have ID, then you concat the user with the ID, then you concat user with the email, ID, email, and country, and is the user active, what is the lifetime value, and what is the updated timestamp, right? So um, so save bronze path must be an absolute volume, right? Bronze path must be an absolute. So what I'm gonna do, like, so what you do is you create bronze path equals to this, right? Because let's ask Genie to do it. Let Genie do some work. I'm just stopping Genie, and I want to cancel this. let's run Genie again, Yep. Let's see what Genie does. It will work, right? It will change. What did it change though? No idea what did it change. Let's see, where has Genie gone? So it updates the code of cell 3 as well as cell 5. Hmm. What change did it make in cell 3 though? So I want to see what is the bronze path first. Let's see, print, because I have no idea what bronze path is, right? Because it may change in each notebook, and I just want to see what it is, right? So this is my bronze path. You create a bronze customer table which is in the type bronze, wherein you have every detail. Let us see whether it has created or not. Refresh it, go to pipeline module, right? Bronze, customers. So this is it, right? And you can see the table. We want to see the difference, right? I want to see the difference in the bronze table and the silver table data, right? Let's see it, why not? Extract from this, right? And I would again use Genie to, because I'm a bit lazy, so I just want to use Genie to understand, It will say, oh, it has an error, right? So why, but it's fine, you want to use Genie to, why does it have to allow me? I don't need to run them, again, which is stupidity, right? So what I would do is, so yeah, it sometimes acts stupid, right? Yeah, I should say this, but yes, it is. Yeah, now it identifies the error because the error is in the path of the table, right? Although the data is in the Parquet format, you can still see the data, right? Yeah, now it does, like yeah, you can see the data, right? Bronze and silver, right? So you can see the bronze table, right? I also want to see the data in the silver table, right? Why not? I want to see the data in the silver table. See the data. This video will be a bit longer, but it is worth it, right? It's if because if it helps people, then that's it, like because I want to do that, mm, 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 mm. So instead of bronze, what you do is just change the folder, you know, and we'll see the difference, right? I mean, if you want to see the difference, you have to compare by their IDs, what has changed. So is user active, true? So there are some derived columns, right? So if you can see in the bronze table, updated timestamp, full name, email, right? Wherein you have country, load timestamp, record source, right? Also, you have customer ID, full name, right? Customer ID, full name, country is active. How many columns are there, right? Um, so there is an additional column which is record source, CRM initial, right? Which is coming from this, right? You create a load timestamp, current timestamp, right? Bootstrap Silver with the initial load, no merge needed on the first run. All right, let's go ahead. Now what we do is change data capture, which I've been talking from the beginning. Receives a CDC batch containing 20,000 updated customers, right? 5,000 new customers with these IDs and 1,000 deletes is active set to false. So there is a change happening, which is like the new customers, and there are few customers which have become inactive. Now we need to update those existing customers, right? So let's run this. 5,000 new inserts, 20,000 updates to existing customers, 1,000 soft deletes, combined CDC batch, right? Now, yeah. So what I have done is this is done in multiple commands, right? Like multiple operations, which is update. What you did is you have updates to the existing customers, right? You have inserted new records, which is good. You have combined the CDC batch, right? Insert or delete, they both are done, right? So these are two separate operations which are being done. They have been overwritten onto the existing table, right? So yeah. So updates 20,000, inserts 5,000, soft deletes is this. I want to do this using a single operation, atomic operation, which is merge and update. So what you would do is, as a delta table object, read the incoming CDC batch. In the bronze, I did it separately, but in the silver layer table, I want to do it using the merge update, right? Yeah. So it says when matched update, then this condition, when not matched, you want to insert a new record, you do this, right? Again, this is quite important to understand. And I'll show you one thing as well. Let me rerun this first. Yeah, so we can see that merge is completed in 8.32 seconds, and what you can see is performance, right? So in the performance, if I go in here, if I go to the query profile, right? Optimizing query and pruning files, executing total wall clock duration, see query profile. So it scanned this number of rows, then it converted into this, then a bit of shuffling happened. Yeah, so that's how you can read. So you can see that bytes written are this, rows read are this, rows written are this, right? Files read are 59, and 59 files are what? It's your Parquet files, right? The records. Um, Now you validate these merge results. You see the count, right? What was the count earlier and how the count has changed, right? Yeah, I think this code, this notebook is good enough for you to understand and to also pass your Databricks Data Engineer Associate. And I think it's more than that, to be honest, right? So yeah, you can see, right? Email, updated timestamp, load timestamp, right? So expected 105,000, 100 plus original units, a sample of updated customers, how they have been updated, right? So of inactive customers, expect 1,000 new customers. There's schema evolution, right? So real pipeline must survive upstream schema changes. So yeah, like if there is a schema change happening from the source file, right? And I'm not aware of it, right? What if like my job runs? It should still be able to handle the schema evolution, right? There is a new column which is being added, loyalty tier. So this is there. Let's run this. Source adds a new column. This would fail without schema evolution enabled, right? Let's see. Yes. All right. So this is customer ID, full name, email, string is active, lifetime value, updated timestamp. Yeah. So I don't know whether this cluster serverless allows the schema enabled to be true or not. Like, let us see, because it was failing earlier, so it might fail again because this cluster is not allowing this. So yeah, so I would not worry. Let me see what I can do. Because of this, I'm using a Databricks free edition, right? Um, Escape. No, it tracks the previous historical state, right? Yeah, cell three is like the beginning of the cell where I was trying to set up. Yeah. So let us see what does it say. I have no idea whether it's gonna work or not. Mm, Resolve load timestamp. Genie is smart enough to understand, right? Let us see. Actually, it's like it's not able to write it. Yeah, I think there is something with the serverless. Let's see, allow. What does it say? Now it want to insert all the records, which is not a correct way to do it, to be honest. Cannot resolve null data insert because, yeah. Let me check again. If auto-merge config was actually applied. Documentation shows that I should use with schema evolution the merge chain instead, all right. Let us see, it has made a lot of change. Genie is getting better, right? Yeah, it ran, right? So it did make a change. Let me see what does it with schema evolution function is being used for this merge operation, right? I was using the configuration, but I wasn't able to set it because it depends on the compute you are using. So so yeah, I just use the with schema evolution function for evolving schema, and this column has been updated. So, so I've updated the new column. Can we see that the new column? I want to see. Let's take. No idea. I wanted to see the records, right? In the I did run a query somewhere. So is it the default silver customers, right? Let's copy this. Let's go down. I'm just adding a cell, which is not a good idea, but again, you know what? I just want to see. And what you can do is you can also see here, right? Describe history or something is there, which shows the history, what sort of operations have been applied to the table, right? And it will show you, like you can see, right? So these sort of operations which we did. So first operation was we wrote onto the table around 130, then we actually merged it, right? Then there is an optimization, then again there is a merge, right? And what sort of merge was done, you can see it, right? And what you can also see is the schema change, right? I just want to show you the schema change happening. So you can see there is a loyalty tier column is added. Earlier it wasn't, and this can also be seen as like this version as of 3, right? let me see, or maybe two. I have no idea. Let me see. I want to ask the genie to fix this error, right? Because you can have different schema for different version of the table. Can you fix this error? I think if this is an in-depth video. I hope you guys like this video, so let's see, as of version, right? Um, Still shows up an error. Why is it showing an error? Let me see. Because I'm using history, like I shouldn't be using history version as of version. Let me use this genie skip. No need to do it all the time, but that has already been done, right? So I'm not sure. I'm asking of this one. So mm, mm, mm. That's what the problem with, like, when you heavy use the DATABRICKS, start asking you to reload. Didn't apply to the correct cell. Let me check cell and UID mapping. So let's see, it will show you the current version. I don't think so. I don't want to check my history though. So version, just remove the version, right? You can always see the version. I just would just run, accept and run, right? I kind of knew it was showing the schema, right? It will. And if I go in here, describe history, right? So you can see 0, 1, 2, 3, right? All right. I think that should be good enough. I'm just trying to show you the history, right? And isolation level is blind appended. So these are the different metrics, right? And who actually made the change, which cluster made the change, which notebook made the change, right? I hope now what we do is there is the Z order. The most common merge operation is a full shuffle. Delta must scan every file in the target to find matching rows with the same. So what is it's doing is it's trying to align the customer IDs which have the customer ID which have the same value files. They should be put together, right? Let's see, and I will rerun this describe history again, to show you the change happening. So that it's easier for people, and it will take a bit of time. Let me rerun this to show you, how the operations in Databricks are so visible, right? Which I really like. What is happening? It's actually should be a SQL, not a Python. I don't wanna. Why is it not working though? Let me rerun this. I want to use the SQL cell. Whenever I'm using SQL cell, it's showing me an error, right? But why? Maybe I've overused my compute. I have no idea, right? Let me rerun this again. You'll see another operation happening onto the table, right? Yeah, optimize. So I've clustered the files which are the same cluster ID. Let me go in here and see, does it have really changed anything, Because for me, the main changes, can I see those changes, right? It was customers, right? So orders, the customer ID, and if I see in here files, right? So bronze, silver, this overview. Where has it gone? customer. So there is a deletion vector, right? These were the earlier files, then they have been merged, brought together, right? And this is also a delta log, right? Yeah, all right. So repartition the source data frame on the join key to align shuffle with the target's file layout. This reduces cross-node data movement, right? So you want to keep the files which have the same values onto the same partition so that you do not have to move them around and it avoids compute cost. Let me run this again. Using custom node, using PySpark already is not allowed on serverless compute, so you can't do the RD, it's fine. I guess, let me run this. I've, all right, and merge operation. Now that there's the same history thing, right? Which I was doing earlier. It's just the way you want to see things. Yeah. So it gives you a full history, but that I think that one is much better, where you have version, timestamp, operation metrics. So that all I've showed earlier. So I guess I hope guys you like my video, and I'm able to explain things in detail. So please support me, and do subscribe to my channel so that I can make more of these videos. This was an in-depth topic today, and I hope I was able to explain. Thank you.